All right, we are going to take notes over finding the zeros of polynomial functions. So we've got examples of ones that you should already know how to do down below. So this first one is a linear function, which means if you were to graph it, it's just going to be a line that goes through a -4 as a y-intercept. And this right here, if I can mark on here, is my x-intercept right there. And so to find that algebraically, we just set y equal to 0, and then we solve for x, and we get x equals 4. So that's our 0 for that function. All right, on the next one, this is a quadratic, which means it's a U shape. If I set the y equal to 0 and then factor, I get x minus 2 times x minus 2. So if we were to, we've got the same factor, so we solve for x and we get x equals 2. And because we've got the same factor twice, that means it's going to bounce at that x-intercept. It's just a U shape that looks like this, where it has an x-intercept right there at 2. All right, on the next one, if we were to factor it, set it equal to 0, we get x plus 3 times x minus 3. It's a U shape that has x-intercepts at 3 and -3. So it looks like that. Again, if you were to have solved that, set each factor equal to 0, and you get x equals -3 and x equals 3. Those are my zeros. All right, on the next one, I want you to think about the graph of this one. This is a normal quadratic that has been shifted up 9 units. So right here at 9, that's where my vertex now is. And it looks like this. So if you'll notice, we're not crossing this x-axis at all. So that means that there are no real solutions. And if you were to set that y equal to 0 and solve this, I'm going to move the 9 over so it becomes negative. And then we're going to take the square root of both sides. When you take the square root of a negative number, you're going to get an imaginary answer. So this is going to be plus or minus. And also, remember, when you take the square root in order to solve, you always get plus or minus outside that square root. So that would be plus or minus 3i equals x. So we have 2 imaginary solutions for this one. All right, let me scroll this up. All right, 2 more. Now notice this is a difference of squares right here. So it's going to factor to be, so I'm going to go ahead and set it equal to 0. X squared plus 4 times x squared minus 4. Now this is going to factor further. So that first factor will stay the same. And then that one will factor to be x plus 2 times x minus 2. So if you set each factor equal to 0 in order to solve for x, this first one, when you move the 4 over, it's going to become negative. And so when you take the square root of both sides, you're going to get the same situation that we had on the last problem. So it'll be imaginary. So you're going to have plus or minus 2i are my 2 imaginary solutions. If I move the 2 over here, I get x equals -2 and x equals +2. So these are my 2 real solutions, and then these are my 2 imaginary solutions. All right, on the next one, I'm going to pull out an x as a GCF. Now notice this one's very similar to that, so I know I'm going to have 2 imaginary solutions like I did before. But remember, you've got 2 factors. You've got x and x squared plus 9, so you set each factor equal to 0. Now this is one of my zeros. It crosses at the origin. And then the other one is going to be imaginary, because that's -9 when you move it over, so x equals plus or minus 3i. So 2 imaginary solutions and 1 real solution. All right, let's talk about how you can't always, it's hard to factor some of these polynomials, especially if the degree of the polynomial is like x to the 5th or something. So we have the rational root test to help us out with that. So if you'll notice, we have this right here as our constant. It won't have any x attached to it, it's just a number. And then you've got your leading coefficient, the number that's in front of the highest degree term. And if you, I don't know if you can hear my dog snoring, sorry. If you take all of the factors of that p-value and all of the factors of the leading coefficient, the q value, and then you do p over q, those will give you possibilities for zeros. Okay, let's do some examples of those. Okay, so for example, this right here is my p, and the number in front of x to the 4th is my q. So the p value is 6, and if I find the factors that make up 6, it's going to be plus or minus 1, 2, 3, and 6. Q is thankfully 1, and the factors that make up it are plus and minus 1. So when we do P over Q, we're going to do every P over every Q. So I'm just going to go ahead and put plus or minus here. It'll take care of all those. And then we've got 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Okay, so I want to see what the actual zeros are. So to do that, I'm going to do synthetic division. If I get a remainder of 0, then I know it's a 0. Another way to do it is to use your graphing calculator, graph this, and actually see where the zeros are. But let's make it hard. So first thing I'm going to do is I'm going to try 1. I usually always try 1 first. So put the coefficients of each of those terms. When I do the synthetic division, this is what I get. Well, I end up with a remainder of negative 8. So 1 is not a 0. So let's try another one. And now my dog is eating his bone, so you get to hear that too. Sorry. All right, so negative 1. So negative 1, negative 2, 2, 3, negative 3. Negative 6, and then positive 6. So I now have a remainder of 0. That tells me that this negative 1 is actually a 0, since my remainder is 0. Okay, so I'm now down to an x cubed. Remember, this was x to the 4th, this was x cubed. So let's try another one. Let's try 2 and do synthetic division again. And I end up with a remainder of 0. So that tells me that 2 is also a 0, since this remainder is 0. All right, so what I know right now is that I have factors that are x plus 1 from that first root, x minus 2 from the second root, and then my result ended up being x squared plus 3. Now, if you'll remember, this is going to give, this one right here will give me imaginary roots, and so my two real roots are negative 1 and 2. All right, let's try another one. On this next one, my p-value equals 3, which means my factors are plus or minus 1 and 3. My q-value is 2, which means my factors are plus or minus 1 and 2. So when we do p over q, we're going to do each p over each q. So plus or minus 1 over 1 and 1 over 2, and then plus or minus 3 over 1 and 3 over 2. All right, these are all of my possible roots. So let's see which one it is, or which, I mean, you have, remember, 3 roots, 3 possible roots for this. So do synthetic division to figure it out. All right, I'm going to start with 1 again. And yay, that one worked. Okay, so remember we started with an x cubed, which means this is x squared. Once you get it to an x squared, you can factor that. So right now we know our factors are x minus 1, that comes from the root that I know we have, and then what I was left with after synthetic division was 2x squared plus 5x minus 3. And that factors to be 2x and x multiplied to be 2x squared. I'm going to put a 3 here and a 1 here, with a plus there and a minus there. So this is the factored form of that polynomial. My roots are going to be x equals 1 from that first factor, x equals 1/2 from the second factor, and x equals negative 3 from the third factor. And those are my zeros for this function. Again, you can't have any more than 3 because of that x cubed right there. So that's it. Let's do another one. All right, this next one's a little harder. We had to give you a hard one, right? My p-value is 12, and my q-value, I can't write q, sorry about that. Fix that. And well, now I can't write. And my q-value is 10. All right, so my factors that make up 12 are 1, 2, 3, 4, 6, and 12. The factors that make up 10 are 1, 2, 5, and 10. So when we do P over Q, we're going to get a lot of results because we have to do each P over each Q. If they simplify to be one that you already have, you don't write it again. So let's start with 1. 1 over 1, 1/2, 1/5, 1/10, and then 2 over 1. 2 over 2 is just 1, so we don't need to write it. 2 over 5, and then 2 over 10 is the same thing as 1/5, so we don't need to write it either. Now let's do 3. Oops, that didn't write very well, sorry. So 3 over 1, 3 over 2, 3 over 5, 3 over 10. Now let's do 4. 4 over 1, 4 over 2 is 2, we've already written it. 4 over 5, 4 over 10 is the same thing as 2/5, so we don't need to write it. Now let's do 6. 6 over 1, 6 over 2 is 3, 6 over 5, and 6 over 10 is the same thing as 3/5. And then we've got 12 over 1, 12 over 2 is 6, 12 over 5, and 12 over 10 is 6/5. So those are all of my possible roots. So let's try some. So I'm going to do synthetic division. Let's see. Put my coefficients first. Bring down my -10, and now I'm going to think about which one I want to start with. I'm going to start with 1, I guess. So 1, we've got, oh, I can already tell this one's not going to work, so let's try another one. All right, let's try 2 this time. Oops, that didn't write. All right, so we have a winner. We ended up with a remainder of 0, and so I know that x equals 2 is one of my solutions. I also know that I started off with an x cubed, so this is -10 is an x squared. So right now, my factored form for this is x minus 2 from that 0 that we just found, and then -10x squared minus 5x plus 6. Now this is awful, and I'm going to use quadratic formula to find the other 2 roots because I don't even want to try to factor that. So we've got x equals a -b, so -5 plus or minus the square root of b squared minus 4 times my a value times my c value all over 2 times a -10. All right, that gives me a +5 and then 25 plus 240, I believe, all over -20. So I'm left with 5 plus or minus the square root of 265 all over -20. Now 265 I think is 5 times 53, so it's not going to simplify any further. So these are my other 2 roots along with that x equals 2. So my roots are x equals 2 and then 5 plus the square root of 265 over -20 and 5 minus the square root of 265 over -20. And that's my answer. You can get the decimal values of those if you wanted to actually graph it, but for our purposes, that's all we need to do. All right, let's do another one. I'm going to scroll this up. All right, so the next one, my p-value is 8. My factors for it are plus or minus 1, 2, 4, and 8. My q-value is 1, thankfully. So when I do p over q, I'm just going to get plus or minus 1, 2, 4, and 8. Yay. All right, so I'm going to do synthetic division. I want you to notice you're missing the x to the 4th value. So I need to remember a placeholder. I'm going to start with 1 on my synthetic division. If your teacher's nice, she would have given you one that has 1. That's usually the one I always start with anyway. So working this out. All right, we have a winner. So we have a remainder of 0, which tells me that x equals 1 is one of my solutions. All right, let's try another one. I'm going to do -2. Maybe because I know that's the answer. And I get a remainder of 0, so that was one of my roots. Now, you can keep going and find another one if you want to. This one, though, if you can kind of tell, this isn't going to be too hard to factor. Right now, you know your factored form for this will be x minus 1 from that first root, x plus 2 from the second, and then our result right now is x cubed minus x squared plus 4x minus 4. We can factor that by grouping. So we've got x minus 1, x plus 2. Remember to do this by grouping. You're going to pull out your GCF there. That'll be x minus 1. And then my GCF here would be 4. And then we've got x minus 1 times x plus 2. So my GCF between this term and this term is x minus 1. And then I'm left with x squared plus 4. Okay, so those are my factors that make this up. And if you notice, you've got an x minus 1 written twice. So we could write that as x minus 1 squared, and then x plus 2, and x squared plus 4. All right, so your zeros are going to be from that first factor, x equals 1. From your second factor, x equals -2. And then remember, when you have x squared plus 4, you're going to get imaginary factors, because when you move the 4 over, you're going to get plus or minus 2i. So those are my two imaginary solutions. All right, so we have a total of 4 solutions. We have 2 real and 2 imaginary. And one thing I want to talk about is how you will always have an even number of imaginary solutions. And our total number of solutions, real and imaginary, always have to add up to be the same number as our highest degree term. And remember, this 1 was used twice. So we've got 2 from that x-intercept, 1 from the -2, and then these 2 imaginaries. All right, so let's move on. Okay, so what I just said was there are always an even number of imaginary roots. So I just kind of hand wrote that on there real quick. So we have something called conjugate pairs. When you know that you have one imaginary root with a plus sign, there's also going to be another one with a minus sign. Those are conjugates of each other because you have to have an even number of imaginary roots. So, for example, if you're told that one of your zeros is 3 plus 2i, another 0 has to be 3 minus 2i. That gives you an even number of imaginary roots, and it's this right here is the conjugate of the original one we were given. The imaginary part, one will be a plus and one will be a minus. That's what makes it a conjugate. All right, so let's do an example. Okay, so they want us to write a 4th degree function in polynomial form, not factored form, with these with these zeros right here. Okay, so right now what I know is that my roots are x equals -1, x equals -1, and x equals 3i. Because x equals 3i is one of my roots, so is x equals -3i. So I'm going to put those in factored form. So that's x plus 1, and we've got another x plus 1, and then we've got x minus 3i from this one, and then we've got x plus 3i from this one when you move those over to be on this same side of the equal sign with the x. All right, so that's what our factored form is so far. All right, so I'm going to go ahead and multiply that out. I'm going to multiply these two first. You're going to do x times x, which gives you x squared, x times 1, and 1 times x gives you 2x when you combine those, and then 1 times 1 is 1. All right, I'm just going to rewrite these for now. Now, if you'll notice, these are a difference of squares. So that middle term is going to cancel out, but I'm going to go ahead and show my work. I'm going to leave the first one alone. So we get x squared plus 3ix minus 3ix minus 9i squared. Okay. So that leaves me with x squared plus 2x plus 1. Those cancel, so you're left with x squared minus 9. Remember, I squared is the same thing as -1. I'm really showing my work here. So we've got x squared plus 2x plus 1, and then we've got, x squared plus 9. All right, now we need to multiply that out. Remember, every term in the first parentheses gets multiplied times every term in the second parentheses. So x squared times x squared is x to the 4th. And then x squared times 9 is 9x squared. Now multiply 2x. So 2x times x squared is 2x cubed. And then 18x. And then 1x squared. And then 9. And then that simplifies to be combining like terms. We have x to the 4th plus 2x cubed. We've got 10x squared, 18x, and 9. And that is our polynomial form, I really should say, equals f of x for that function. All right, let's do another one. Okay, on this next one, remember when we write a polynomial, we have a leading coefficient with our highest degree term, and then you've got your next term, which is a degree lower, and your next term, which is a degree lower than that, all the way down to some constant value. So we could have some value other than 1 in front of that highest degree term as our leading coefficient. So this right here is telling me I'm probably going to have an a value that I need to worry about. So right now I know my zeros are -2, x equals 1 plus the square root of 2i, which means that 1 minus the square root of 2i is another 0. And I have 3 roots here, which corresponds to the fact that this has to be a 3rd degree term. All right, so moving that -2 over, that gives me a factor of x plus 2. And then moving each of these over, they have to change signs, so that'll be x minus 1 minus the square root of 2i. And then on the next one, it'll be x minus 1 plus the square root of 2i. All right, those are my factors that make up this polynomial. Okay, so multiply this out. I'm going to show my work. I'm going to multiply everything. I'm going to multiply these together first. So x times x is x squared. X times a -1 is a -x. Plus the square root of 2ix. And then I'll do the -1 times everything. So -x plus 1. Oops, sorry about that. Minus square root of 2i. And then I'll do the next one. So a negative square root of 2ix, and then plus square root of 2i, and then minus square root of 2 times square root of 2 is just 2, and then we've got I squared. All right, so that equals f of x. So we've got x plus 2. Let's do some simplifying. We just have this x squared. We've got a -x here and a -x here. So those combine to be a -2x. This square root of 2ix will cancel out with this one, so that's gone. These two should cancel. Again, when you multiply conjugates, all the imaginaries should cancel out. Then you've got plus 1, and then you've got that minus 2i squared, which is really a -2 times a -1. Okay, again, that equals f of x. So you've got x plus 2. And then x squared minus 2x, and then that gives me plus 3 equals f of x. Now we need to multiply all of that out. Now remember that technically every one of these had an a value in front. I forgot to be writing that, I'm sorry. That a value is the leading coefficient, so I'm going to keep that there. I'm going to go ahead and multiply this out. So x cubed minus 2x squared plus 3x plus 2x squared minus 4x plus 6. All right, so that's completely multiplied out. Now I have to focus on the fact that they gave me this right here, that f of -1 equals -34. So I'm going to replace that with a -34, and that means I need to replace all of my x's with -1. And that will help me solve for a. So we've got a negative 1 cubed minus 2 times negative 1 squared plus 3 times negative 1 plus 2 times negative 1 squared minus 4 times negative 1 plus 6. So that's a negative 1. A negative 1 when you square it's a positive 1 times that negative 2, and then minus 3 plus 2. Plus 4 plus 6 equals negative 34. All right, combine all of those. We get 6, when we combine them all, equals negative 34. So if you solve for A, you'll get negative 34 over 6, and then simplify that, you get negative 17 thirds. That is a yucky A value. So, and I forgot, I was just realizing as I was working this, I didn't simplify this. We had this right here ended up being A times x cubed. Those will cancel out, and then we've got minus x plus 6 equals our f of x. And so our A value we just found to be negative 17 thirds, and then x cubed minus x plus 6. And that equals f of x. All right, so that is our polynomial using those zeros and the A value that they gave us. Okay, that's it for our notes on 2.5. Thanks, y'all.